So lesson 40, you'll notice it's units as a derivative, normal lines, maximums and minimums on a graphing calculator. So you will need your calculators out for when we get to that portion. But before we get there, we are talking units of the derivative. There's a key point right here. I'm going to star. We've talked about derivative in the past. What have I told you about derivative in the past?
That is going to keep showing up.
It's going to keep showing up. It's the slope of the tangent line, right? Okay, so don't forget that. When we talk units, when we talk word problems, okay, derivative is the rate of change of a function. Okay, so when we talk derivative, rate of change of the function. And if you think about that, slope. Slope is a rate of change because it's the change in y over the change in x. Same idea, it's rate of change. So all these problems today, or at least here in the beginning, are going to focus on how derivative is rate of change. As we look at example 1, let's read through it, and then we'll backtrack and talk about the pieces. The distance s of the particle from the origin is given by the equation s equals t squared plus 3t plus 7, where s is in meters and time t is in minutes. What is the rate of change of the distance with respect to time when time equals 4 minutes? Okay. Cassie shakes her head. I get it.
It's because you read it, but at the same time, it just went in and out.
I get it.
As simple as it sounds, or as it looks, I don't see it.
And this one is simple, actually. Now, do I expect you guys to see the simplicity of it right now? No. Okay. But, okay, so first of all, what does S stand for? S is distance. So this equation right here, S equals t squared plus 3t plus 7. And in fact, I'll even write that down. S equals t squared plus 3t plus 7. That is your provided distance formula. Okay? T obviously is time. And they even go as far as to specify as S is meters and T is minutes. Now, the question they're asking me is, what is the rate of change? What did we just mention about rate of change earlier? Rate of change is the derivative, yes? Okay. Rate of change is the derivative. So if they're saying what is the rate of change, what are we being asked? What is the derivative? Now, it says what is the rate of change or derivative of what? Of distance with respect to time. When time equals 4 minutes. So we're given this S equals equation, and it's in terms of t. We're asking for the rate of change, the derivative, distance with respect to time. How can we write that, what they're asking us to find? It's the derivative of distance with respect to time. Or, what if I say ds over dt? Does that mean something to you? A lot of times we talk dy over dx, right? But I'm not talking dy dx here because my equation doesn't have y's and x's. My equation is s and t, so that's why I'm talking ds dt. Distance with respect to time. What are we going to have to do with 4? Plug it in at the end, right? So we're trying to find the rate of change for the derivative, and then we'll, at 4 minutes, means we'll plug 4 in at the end. So can you do it? Derivative of s, so that's my ds dt. Derivative of t squared, 2t. Plus derivative of 3t, 3. Derivative of 7, 0. So what am I going to do now with that derivative? Plug in 4. So notation-wise, I'm going to do ds dt evaluated when t equals 4. So you'll notice it's ds dt. That line afterwards, that vertical line is just kind of saying when or evaluated at t equals 4. So, mathematically, 2 times 4 plus 3 is 11. What's in my label here? It was a change in distance with respect to time. Distance over time. What are my distance and time labels? Meters and minutes. So this is 11 meters per minute. And I'm saying meters per minute because they told me my distance is in terms of meters, my time is in terms of minutes. Jack, what word did you just throw out there? Velocity. And then on the next problem, you'll see me connect it all. But this is the lesson we start talking about velocity. Okay. The rate of change is velocity. Now, curiosity. All right, any of you who's done physics? Only 2 of you? Okay. So I was kind of curious where we're at on that. So some of this will seem familiar in a different way to physics. Was this last year or is this year?
We took it last year.
Okay. So meters per minute, that is a velocity label. Okay. Questions on that one before I move to example 2? Overall, it wasn't a bad problem in the end, right? At least I hope not. Jackson, are you giving up on me already? Oh.
It's a bad time of the year for everybody.
Okay. Let's try example 2 then. The velocity of a particle in meters per second is given by the quadratic equation v equals 4t squared plus 2t plus 4, where t is in seconds. What is the acceleration of the particle when t equals 3 seconds? Okay. So what are they giving me?
Velocity.
They're giving me velocity. What do they want me to find? Okay. They're asking what is the acceleration, right? On the last one, they gave me distance. I took the derivative, I got velocity. This time they're giving me velocity. What do we think? What are we going to have to do with this velocity equation to get acceleration? Take the derivative. Okay. Now, before I actually start into this, here's the big connection I need you to make. There's I kind of tear it in my head. But if distance is your base, okay, so if you have a distance equation or whatever, that's in terms of meters, the derivative of distance, or in other words, the first derivative is velocity. Your velocity would be something like meters per second, where it's a distance per time. So if you start with distance, the first derivative of distance is velocity. The second derivative, or in other words, the derivative of velocity is acceleration. And when you do acceleration, we generally label it as meters per second squared. Okay, that is a connection that we will do a lot with throughout calculus, where you need to understand that if they give you position or distance, the derivative of that is velocity. The derivative of velocity is acceleration. Okay, so you'll see a lot to do with that. Now, back to the question they gave us. They gave us the velocity of 4t squared plus 2t plus 4. How am I going to find acceleration? Take the derivative. Now, if we use the d's to label, it'd be the derivative of velocity with respect to, what variable is here? T, time. So I can label this as dv dt. So what's the derivative of 4t squared? 8t plus 2 plus, that's it. It said what is the acceleration and what was the rest of that problem? When t equals 3. So what do you do here? Plug in 3 for t. So we're finding dv dt evaluated when t equals 3. And what do we get? Okay, 26. We took the derivative of velocity, so we took the derivative of meters per second, which means it's now meters per second squared. And this is acceleration. Okay. That's not bad, is it? Okay. Again, memorize, no. Distance, velocity, acceleration. They're each separated by a derivative. Okay. Normal lines, if you may. To my knowledge, this is the first time you hear the introduction of normal lines. I don't know why, but it was the first time I remember it. In math, first of all, that should say the word normal. The word normal does not mean ordinary. It means perpendicular. So if in homework you see something that says find the equation of the normal line, that is their way of saying find the equation of the perpendicular line. Right. I find it weird that this is the first time you ever hear the introduction of normal, and all along the line you hear perpendicular.
Why wouldn't they just say perpendicular?
I don't know, but it's a typical calculus word for them to ask about the normal line.
So what do you call an actually normal line? Just a line?
Yeah. I mean, how, you wouldn't describe a line as a normal line, just a regular line as a normal line. You would just say a line, so. Okay. So, example 3. Find the equation of the line normal to the graph of y equals e to the x at x equals 1. So, what are they asking me?
Find the line that's perpendicular to the y equals e to the x.
Okay, you guys got her? They said normal. Basically, they're saying find the equation of the line of the perpendicular line. What do we know about perpendicular lines?
They cross.
Okay, so they cross at a right angle. And what about their slopes? It's what? And? Flip it. Okay. I usually use the phrasing opposite reciprocal slopes. Opposite meaning you change the sign. Reciprocal meaning you flip it upside down. So perpendicular lines have opposite, reciprocal slopes. So there is your friendly little, I would say Algebra 1 reminder, but it might have even come up in pre-algebra. It's been a while, right?
Algebra 1 was such a blur.
Okay, so perpendicular lines have opposite reciprocal slopes. What do we have to do in this example we're being asked to find? We have to find the equation of the perpendicular line. What do we need to start by finding? And why are we finding the derivative? I agree. We're going to find the derivative. Okay, because derivative is slope, right? Derivative is slope of the tangent line. So we've got to be able to find the slope of this line. Okay. So in order to find slope, we're going to find the derivative. If we're given the equation y equals e to the x, what's the derivative of that? Derivative of e to the x is e to the x, yes? So y is e to the x, and dy dx is e to the x. Now, specifically, where do we need to know the slope of this line at? We need to know the slope, but specifically at what point? At x equals 1. So we know the slope of the line is e to the x in general. What is the slope of the line at the point x equals 1? Yeah, you plug in 1, and it's e to the first, which is e. So what is that I just found? Okay, this is the slope of the tangent line. Is that the slope I'm eventually going to use?
No.
No. But you have to find that slope to get started, because that is the slope of the given line. What slope am I going to have to use? You guys like his answer, negative 1 over e? How would he get that?
Flip the sign.
Yeah, it's the opposite reciprocal slope, yes? So the opposite of positive e is negative e. The reciprocal of e is 1 over e. So my normal slope is negative 1 over e. That's the slope I'm going to use here in a little bit. What else do I need to write a line besides a slope? Okay, a y-intercept, or generally speaking, generalize more. Does it have to be the y-intercept? It really could just be, even to get the y-intercept, we have to have some kind of point on the line. How can I find a point on the line? Or a point on the curve, I should say. We have x equals 1 given here, yes? We're trying to look for this equation at the point x equals 1. 1 comma what? What's the other half of that point? How do we find the other half of that point? Let me ask it that way. We're going to plug it into the original equation. Okay? Sorry, I was looking at how I wrote it in here, and I was confusing myself. So if we know it's x equals 1, if you plug that into the original equation of e to the x, so it's e to the first, that point then is 1 comma e, and that's the point we're going to use, because that is the point where my curve and my tangent line intersect. So in my notes, this is what I was confusing myself. I have it written as the point of intersection. In other words, it's a point on the curve and on the tangent line. Okay. I have a slope and a point. How do we write the equation of a line when we have a slope and a point? Okay. Jack says he's going to use point-slope form. You can use point-slope form, or you can use slope-intercept form. If we use slope-intercept form, we have to find b, correct? Are you guys, I don't know, how do you guys feel about me using point-slope? Can I use that? I know I've been using it, haven't I?
I'm sorry, I have snot
Yeah, I'm sorry, I couldn't hear you.
and a lot of it.
Okay, so if I use point-slope form, guys, I'm going to try it y minus y1 equals m times x minus x1. So y minus, what's my y point coordinate? E equals m. What's my m? My normal slope was negative 1 over e times x minus, what's my x coordinate? 1. Okay, looks like I gave it as y equals. There's different ways you could give this. I would go ahead and probably distribute. So y minus e, this is going to be what? Negative x over e? Or negative, I guess I leave it as negative 1 over e times x. Minus 1 over e times plus 1 is going to be plus 1 over e. Then how do you solve for y? If it's y minus e, we can add e. So y equals negative 1 over e times x plus 1 over e plus e. That would be one way to leave your answer. I'll be honest, I have something different in my notes. Okay? But notice I left the e's in here. I did not change them to a decimal, did I? No. This is my exact equation. I did no approximations. If we go to decimals, you are now approximating your slope and approximating your y-intercept. So just kind of an FYI that this is exact. And you need to be aware, if they say something they want it exact, do not change and round decimals. If they want it approximate, then we can change the decimals and do some rounding. Okay. Questions on that one? That's kind of part of the big deal today. Okay. Can we try the second example? It's a lot like it. On the back side, we get to use calculators to do stuff. So, now this one actually says use a calculator. It says as necessary to approximate. They want us to approximate the equation of the line normal to the graph of y equals e to the sine x when x equals 2.7. Meaning, when they say approximate, good. We're not going to leave e to the sine of some power in our answers. We're going to get a decimal answer. Okay? So what are we trying to find again? Equation of the line normal to the graph of y equals e to the sine x when x equals 2.7. Same as the last problem. What do I start with? Derivative, because I need a slope. So in order to find slope, we're going to look at y equals e to the sine x. And we're going to find the derivative. Okay, guys, what do you remember from last week? dy dx. What is the derivative of e to the something? Okay, so remember, you guys remember chain rule? Derivative of e to some power is e to that power times the derivative of said power. Okay, so this is still derivative of e to something is e to something times the derivative of something. What's the derivative of sine x? Cosine x. Now, at what point, I mean, we could clean that up if we want, but at what point do we care about this? When x equals 2.7? So can we go ahead and plug that in? Yeah, they said use the calculator to approximate. So, dy dx evaluated when x equals 2.7. So e to the sine of 2.7 times cosine of 2.7. Your calculator's in what mode? Radians. So I don't have anyone in physics right now, do I? So no one's constantly going back and forth between degrees and radians.
That's in every other class.
Okay.
I have an hour in this.
Oops. So I need e to the sine of 2.7 times cosine of 2.7. Did you guys get it? Negative 1.386155048. Okay, this book uses 4 decimal places. You need minimum of 3 for calc test. Negative 1.3862. What is that? Okay, this is slope of the tangent line. Is this the slope we're going to use? No. What's the slope I'm going to use?
1/1.362.
Whoops, I can't spell here. Gosh. Okay, normal slope. It's opposite, so it's negative. Reciprocal. So 1 over negative 1.3862. Could your calculator do a little math for you there? First of all, what's the negative? And there's another negative in there, so it's going to become a positive, right? So basically, what's 1 divided by 1.3862? 0.7214. And what is this? Yeah, this is our normal slope, and it is an approximation, but we're going with it. Okay, what else do I need besides my normal slope? A point. How am I going to find that point? Okay, so we were given 2.7, right? So we know it's when x equals 2.7. And then what was our given equation? It was y equals e to the sine x. So y equals e to the sine of 2.7. How are we going to find that? E to the sine of 2.7? E to the sine, 2.7. 1.5332.
You got what?
1.5332. No? E to the sine of 2.7.
Would it matter if you're in degree?
Oh yes, you need radians. So my ordered pair is 2.7, comma, 1.5332. That is the point of intersection. We have a point and a slope. Can we do it? Yep. Were you guys okay with the fact that I used point slope form last time then? Okay. I'm not saying you can't go back and use y equals mx plus b form and find your b that way if that's your preference. I'm not saying that at all. So, if I go point slope though, y minus y1 equals m times x minus x1. Y minus try this again. Okay, y minus 1.5332 equals slope 0.7214 times x minus 2.7. Excuse me. And then use the calculator, right? So y minus 1.5332 equals 0.7214x minus, what's 2.7 times 0.7214? 1.9478. I'm sorry, guys. I keep miswriting things here. Okay, then add that 1.5332 over to the other side. So y equals 0.7214x point what? Something's not right. I got minus 0.4146 as my rounded answer. Minor detail, right? I know, it made me double check myself. I'm like, oh crud, we didn't get the same answer. Why not? Again, those are using those algebra skills, right? Okay, we've got 2 quick questions to do on the back. Now, what I can tell you about the back. They're both about approximate, estimate the value of the relative maximum of y equals sine x on the interval 0 to pi. When they say find the value, they're asking for the y value is what they're saying. They're asking us to do this on the graphing calculator, so that means we're going to look at the graph. So approximate the value, it specifically says of the relative maximum, y equals sine x on the interval 0 to pi. So what should we start off doing? Graph. We're going to graph y equals sine x. I like, for trig functions, to use the zoom that is z trig. So if I do y equals sine x and I go to number 7, which is z trig, make sure you're in radians, by the way. I like that. Now, what interval did it specifically say? 0 to pi. What are those 0 to pi values? X's or Y's? X's. So what I would recommend you do then is go to your window settings, hit the window button, and change my X min to, what's the farthest left I need to see? 0. Change your X max to pi, because that's all we need to see is from 0 to pi, and then regraph it. And you're still in Z trig, so So 0 and pi is what I changed those to. Can you find the relative maximum? You should just have one big curve going from 0 to pi, yes? How do we find the relative maximum?
Just do trace.
You can do trace, more precisely though than trace. Second calc, max, which is number 4. Remember, set a left bound a right bound. You can go back and give a guess. When I do my second calc max, what was my max value? My ordered pair is 1.5708, comma 1. Any thoughts on what that 1.57 is? In terms of pi. Pi over 2, yep. Okay. Now, again, that's the ordered pair, which is why I was showing it, but what did it ask me for? The value of the relative max. What's the value of the relative max? 1. If they say, where is the max located? Where is the relative max located? Then it's the x value. Since they said, what is the value? It's just the y value. So on example 6, if they want the minimum, we need to start off by graphing y equals x cubed plus 4x squared minus 7x minus 5. Once you graph it, I would start off with like a zoom 6 or something, but then I would change your window to specifically be 0 to 4. Does that make sense? And then, of course, you could use a second calc and find the minimum. So, x to the third plus 4x squared minus 7x minus 5. I'm going to do a zoom 6. You guys going to beat me there, or were you guys still copying? Okay. And honestly, I'm going to change the window, but really, can you tell from 0 to 4 where the minimum is? I mean, it's the only minimum there, isn't it? But if you want to specifically focus in, you can change your x min and x max to 0 and 4. And you can use your second calc min to get there.
On any of your tests, do you think we'll ever have an encounter where there might happen to be another place that it crosses, or there's an even lower place, it's just not on
the interval? I don't know. I mean, it's a possibility. Will it happen on my stuff? I have no idea. Okay. So there I got my minimum. At 0.6943, comma, negative 7.5972. So what is my relative minimum value?
Negative 7.5972.
You got it. The negative 7.5972 is the value we're really looking for there.